Talia Khan and I am from the Department of Avionics Engineering. Welcome to the first ever episode of the AV podcast. We will use this podcast as an opportunity to explore the field of avionics engineering and further to explore all the queries that people have regarding the specific engineering. For this, we have for our first ever guest is Dr. Suhail Akhtar, and I would like him to introduce himself.
Thank you. My name is Dr. Suhail Akhtar, as Talia mentioned. I am a professor at the Department of Avionics Engineering at the Institute of Space Technology. My educational background is that I have a degree in avionics engineering from the College of Aeronautical Engineering, Pakistan Air Force. And I have a master's degree in control systems from the Université de Compiègne in France and a PhD in aerospace engineering from the University of Michigan Ann Arbor, USA. And my area of expertise or research is flight dynamics and estimation and control of aerospace vehicles.
That sounds so cool. Just to put it out there. It sounds so cool. So would you describe how did you decide to be in this field?
Of course, I wasn't really familiar with what avionics engineering is as, let's say, a young child who is aspiring to enter university. But of course, like other children, I was fascinated with flight. I would make these stick airplanes and try to fly them and stuff. But so the only avenue at that time which could lead to a career in aviation was the Pakistan Air Force, and I joined the Pakistan Air Force. And at the PF Academy, we had two choices as our majors. It was either aerospace engineering or avionics engineering. And from what I have learned a bit about in the first 2 years of our education, I decided to pursue avionics engineering.
Okay. Sir, can you, in the easiest way, describe avionics engineering for people who are not aware of what this field actually is? Because I remember when I joined avionics engineering as well, I was a little confused about what it particularly was and where it would lead me.
Right. So, yes, that is a good question. Actually the answer has many layers to it, but primarily, at let's say the highest level, I would say that avionics engineering is a subfield of the broader discipline of aeronautics and astronautics. In fact, I like to describe avionics as the ears and the eyes and the central nervous system of aviation. So the planes that you see and let's say spacecraft that you see that soar above us in the heavens, they not only do they require propulsion, the engine, and not only do they require their structures and their avionics and their aerodynamics, but they also require other systems that help them see, that help them listen, and then help them track certain trajectories. Now, when you see this space shuttle, well, there isn't a space shuttle program anymore, but when there used to be the space shuttle, when it re-entered the atmosphere, it has to enter at a very precise angle. Too steep, and it will burn up. And too shallow, and it would just skid off the atmosphere. So it has to be now, being able to control something at that precise angle, this is the function of avionics flight control systems. Similarly, the aircraft that we see today, many of them are actually unstable, and that makes them outside the capability of a human pilot to fly. And for that reason, we require constant corrections by a flight control computer. And in avionics engineering, we study the aircraft, and we study the whole computing mechanism that goes into implementing those systems, and also the algorithms that are implementing on the hardware. And so this is like, say, one layer of avionics. But in modern context, it has become much more than that. And the reason for that is that the proliferation of autonomous systems. As an autonomous system, not only aerial autonomous system, but let's say terrestrial autonomous systems, as these systems pervade our society, there will be more and more, there's going to be a need for people who have skills that we impart at the Department of Avionics Engineering. So I said this is the broader level, but we can go deeper on later on.
Sure, sir. Sir, when we talk to younger people who are junior than us and who just have done their intermediate, most asked question that I also get from people who ask me that I do engineering is that what is the major difference between electrical and avionics? And people mostly say this, that why isn't it better that we do electrical engineering than to be specified to one domain and to do a whole 4-year program on that one domain? So how would you describe how it's way different and how it is completely a whole field that people should come to and take part in and be interested in?
So I'm not going to commit myself and say which is better, but I can explain what the difference is,
Okay.
And how that difference might be useful to you. Okay, so there are two main differences. The first difference is that this has a broader view of things. Like you said, since it is going to be applied to aviation in a particular field, so you need domain knowledge to be able to design an electronic device that will fly on an aircraft or a spacecraft. You need domain knowledge of the aircraft. So our students also study, let's say, propulsion, they study aerodynamics, and so it gives you a broader multidisciplinary view of a system. This is one aspect. And the second aspect is that avionics systems are safety critical. Something goes wrong in an avionics system, that has consequences, and that consequences might be lethal, right? So you have to get your design right, and you cannot try something and then see whether it works or not, so it has to be right the first time. And that leads to very stringent design criteria that you have to adhere to when you're designing something, or some particular module for avionics. So this is one aspect, the safety criticality, and also avionics, something that you want to be able to get something into the air, you want to reduce the volume, you want to reduce the weight. These are requirements that might not be an issue in other domains. But here you have your domain knowledge of electronics, but you have to design, you have to adhere to certain design criteria, which are much more stringent than in other fields, let's say. And that's what makes it different.
Okay. I think that's a fair enough answer for people to differentiate what they want to do. I have one more very interesting question that I wanted to ask you. We have around almost 2 to 3 institutes in Pakistan, almost I think so, who are offering the same course of avionics engineering. What would be your top 3 reasons for students to pick IST as their first priority? Because when you're out of intermediate, you're very confused about where you want to go and what you want to do. So what would your top 3 reasons for a student to come to IST?
All right, again, there are 2-3 parts to this answer. Well, first of all, the faculty at this institute is a blend of experience and academic excellence. So on the one hand, you have people here who have, of course, been to the best universities in the world and have gotten their PhDs from the best universities in the world. But also, more importantly, I would say, they have field experience. They have actually worked on physical systems. So somebody who is able to bring that experience to the classroom is worth his weight in gold, actually. The kind of knowledge that such a person will be able to impart will possibly not be possible, probably not be possible for somebody who is a pure academic only. So, because we are talking about an engineering field, applied science, right? So, although we require academic rigor, but we also require it's the relationship between the math or the physics and the real world, and that is what the faculty here brings. Also, like you mentioned, there are 2-3 institutions. One of them, of course, is the Pakistan Air Force Institution, which I'm also a graduate of, but of course, they have limited, it's mostly for military cadets, and they have limited opportunities for let's say, students who are not opting to join the military. And the third thing I would say is that even at the PF Academy, and then there is another institute in Karachi, they do not have that space segment, the flavor of space that we have because of our association with Sparko. You have the opportunity of working on actual hardware that is going to go into orbit. And there are, of course, there are students here working on these CubeSats and such. And we were the first institute which put a CubeSat into orbit in 2013, and we're working on different other exciting opportunities as well. So again, that added dimension maybe is not available in any other institution.
I think since I am a student of avionics engineering, I at least second sir on the fact that the faculty over here is amazing. They know what they're teaching and they're well aware of what is happening in their courses. Sir, one last question I think that every person who is about to join university thinks about. After 4 years of our bachelor's, where will we get our job? And since a lot of people say this, avionics is basically related to aircrafts, so how will we find job opportunities in Pakistan related to that, and how much broader range of opportunities for jobs and earning is in Pakistan for this field?
Correct. Yeah, this is of course again a very valid and pertinent question because everybody is concerned about the fact of how to make a living once he is graduate. Well, our graduates are basically working in three different kinds of, I would say, categories of employment. There are people who work in R&D, research and development, and academia. I would try to club these two together, research and development and academia. And then there are people who work in maintenance, and then people who work in regulatory bodies. And I'll go over them, let's say, one by one. Of course, research and development, of course, when you're trying to make newer and newer systems, then it requires certain research and it requires development of those systems. So the opportunities that within the country that you have for jobs is, of course, the commissions, the strategic commissions, which is NASCOM, and let's say Air Weapons Complex and the other commissions that we have. Also, the armed forces, the three services, they maintain aircraft. They are into some level of research and development, and there are a lot of openings for people with these particular skills in these organizations. And then when I talk about these military being able to develop certain new aircraft or let's say missile systems or whatever, they're also maintaining a fleet of very sophisticated equipment, and they require people to maintain them who have knowledge of these systems. So there's also the maintenance work, and of course this maintenance work is also available in the different airline industries in country and abroad. The third category that I was talking about is regulatory bodies. Of course, when you have an industry which is so large and it has to be regulated, and there are bodies which regulate the industry in terms of its operations and also in terms of the equipment manufacturing. So there will be bodies that decide the operations, when you perform these operations, what are the standards that you must adhere to, such as the Civil Aviation Authority. Okay. And then when I design something, I was saying, I was talking about safety criticality and all of that. So when you design something, you must adhere to certain standards, and you must qualify certain standards for that thing to be, for that particular piece of equipment to be certifiable to fly on an aircraft. And there are organizations which do that. And all of these organizations, again, will require people with domain knowledge so that they are able to set those standards. So yes, this is the third category. And of course, I talked about autonomous vehicles, right? So as this thing, as this particular phenomena is increasing, you have more and more jobs for people with these skills for autonomous vehicles as well. There's this concept of, first of all, there are at least, as far as I know, there are 2 cities in the US that already have driverless cars. There's a driverless taxi service, right? There's San Antonio, I believe in Texas, and then I think it's San Francisco maybe, but I'm not sure. But San Francisco in California, that you just have an app, and just like you Uber here, you can call a driverless taxi. The time is not far away when you will be able to call a driverless or pilotless, I should say, air taxi. Okay. Once you have that urban mobility concept, it is going to be imperative for us to manage the airspace. You have so many of these, vehicles flying around in a very constricted airspace, in a very limited height band, and all of that is going to require a lot of IT infrastructure, communications infrastructure, and the algorithms that will maintain a separation between the pilot and vehicle. This is one of the aspects that we teach at the Department of Avionics Engineering, and I think this is a skill that is going to be in much demand in the years to come.
I think that is a very descriptive answer to the question. So one last thing, is there something you would want to say to the people who freshly join engineering, or people who are thinking about coming towards this field right after their intermediate? Something, a piece of advice or something that would lead them or help them choosing the right direction for their future?
Well, actually, I wouldn't say the right direction. I wouldn't say avionics is the right direction or that is the right direction. There is no right direction. Whatever direction you start to pursue, you have to work hard, you have to excel. You excel in any field, and the world is at your feet.
Thank you so much, sir. The conversation, I think, was very informative, very compact, and I hope a lot of the queries that people had were cleared through the conversation. Until next time, let's hope to see you in the best of health. Thank you so much.
Thank you.